Okay, so let's jump right into this deep dive with something that, oh, well, it sounds completely made up. Right now, as you're listening to this, trillions of particles are passing straight through your body, through your skin, your bones, the chair you're in, and you feel absolutely nothing.
It's a genuinely wild concept, and it's not science fiction. It's one of those cosmic truths that really challenges how you think about reality.
We're talking about the neutrino, right? The ghost particle.
Exactly, and it's probably one of the most fundamental and mysterious forces in nature, one that just operates completely outside of our senses.
Okay, let's unpack this. How can something trillions strong be completely invisible?
Well, that's the mission, isn't it?
Yeah, to figure out the scale of this, why they just ignore us, and I think most importantly, what they can tell us about the secret life of the universe.
And when physicists were first trying to map out all the subatomic particles, the neutrino was, well, it was a necessary but really frustrating piece of the puzzle.
Because it's just so small.
Almost unimaginably small. It's a subatomic particle that has, for all intents and purposes, no volume.
So, to get a sense of the scale, where are all these particles actually coming from? What's the source of this invisible rain?
The main source is the sun. It's the constant stellar fusion happening right in the sun's core,
Just a byproduct of it burning hydrogen.
an immediate byproduct.
Yeah.
But they also come from much more dramatic events. Supernovae, massive cosmic explosions, active galaxies far away. They are literally raining down on us all the time.
And this is where my brain starts to short circuit a little. The numbers. When we say trillions, that's specific to each person listening, right? Not just globally.
That's right. And the sources on this are solid. The number is staggering. In every single second, 100 trillion of these solar neutrinos are passing right through your body.
100 trillion.
Every second. That's not a general number for the planet. That's the density flowing through you right now.
But the number so large just becomes an idea. It loses meaning.
It does.
So if we connect this to the bigger picture, the entire planet is just constantly bathed in this particle stream.
Constantly. They're hitting us, the Earth, the atmosphere, everything. They just flow out of the sun and pass through the solid mantle and core of our planet as easily as, light passes through a window.
Which, okay, that brings up the central paradox. If 100 trillion particles are hitting us every single second, how do we not feel anything? Does that huge number even matter if they don't interact?
That is the perfect question. Because the quantity is almost meaningless without understanding the physics behind it. The way neutrinos interact with matter is described by scientists as, and I love this term, quasi-non-existent.
Quasi-non-existent.
It's basically nothing. They just bypass the whole mechanism that we think of as solidity or touch.
And the sources had that incredible analogy to really drive this home, the one about the lead.
Right. So imagine you want to stop one. You build a wall of solid lead, which is incredibly dense, great at blocking radiation. Well, a neutrino can pass through a barrier of solid lead that is 1 million kilometers thick without touching a single atom.
Wait, say that again? 1 million kilometers.
1 million. That's more than twice the distance to the moon.
Wow. Okay, here's where it gets really interesting for me. If they can go through that much solid lead, our bodies are, we're less than a napkin to them. We're not even there.
We're basically transparent. We're like atomic sieves. And the scientific reason for this is actually pretty straightforward. It all comes down to charge.
They don't have one.
Exactly. Neutrinos are neutral particles, no electrical charge at all.
And why is that the absolute key to them being, well, ghosts?
Because almost every single thing you experience, the feeling of the floor, the light you're seeing, even the chemical bonds holding your body together, it's all governed by the electromagnetic force.
And that force needs a charge to work, a positive or a negative.
Precisely. So without a charge, they are completely unaffected by magnetism, by electricity. They just ignore the entire force that gives us our sense of reality. They only listen to two other, much weaker forces.
Gravity and the weak nuclear force.
Right. And the weak nuclear force is, it's incredibly short range. It's confined deep inside the nucleus of an atom.
So the odds of a direct hit on something that small are just astronomically low, even with 1 million kilometers of lead.
It's almost zero.
Yeah.
But there's another really cool wrinkle here, something that really changed physics. For the longest time, we thought neutrinos were massless, like photons, traveling at the speed of light.
But that's not the case anymore.
Nope. We now know they do have a tiny bit of mass. And the way we figured that out is one of the most exciting discoveries in modern physics. It's called neutrino oscillation.
Oscillation.
Yeah, neutrinos come in three types, or flavors: electron, muon, and tau. As a neutrino travels through space, it actually changes its identity. It oscillates between those three flavors.
So a particle can change what it is mid-flight.
It can. And the math on this is clear. A particle can only do that, it can only oscillate, if it has mass. If it were massless, its identity would be fixed. That discovery won a Nobel Prize.
So it barely interacts with anything, and it can change its identity on the fly. I can see why they call it the ghost particle.
It's the perfect name for it, isn't it?
It really is. But okay, that leads to the next obvious.
Ice cube is the perfect example. They use 2 cubic kilometers of natural, incredibly pure ice, 2 kilometers deep in the Antarctic ice sheet, as their detector.
So the ice itself is the detector.
The ice is the medium. They drill these incredibly deep holes and lower in thousands of super-sensitive light sensors. They call them DOMs.
And they just wait.
They wait. And when that one rare neutrino finally hits a water molecule in the ice, it creates this tiny flash of blue light Cherenkov radiation. And those sensors pick up that flash.
Even with a setup that huge, that, deep frozen and 2 kilometers wide.
Yeah.
What's the success rate?
It's still just staggering. That entire massive array, costing hundreds of millions of dollars, is designed to capture, statistically, just one neutrino out of every billion that passes through it.
1 in a billion. So we do all of that.
Yep.
For what? What's the cosmic payoff? What are these ghosts telling us that we can't get any other way?
They're carrying pristine, unfiltered information from the most extreme parts of the universe.
Because they don't get blocked by anything?
Exactly. Light gets blocked by dust and gas. Magnetic fields bend charged particles. But neutrinos, they travel in a perfectly straight line from their source, carrying all their energy with them. They're like perfect cosmic messengers.
Messengers from what, exactly?
From the birthplaces of the highest energy cosmic rays, from the inside of collapsing stars, from the edge of black holes, and from these incredibly violent, distant explosions called gamma ray bursts.
So we're using them as a telescope to see things that are otherwise completely invisible.
A totally new kind of astronomy. But there's a deeper secret, too, possibly the biggest one. Neutrinos might hold the key to why we exist at all.
How so?
Well, the big puzzle in physics is the matter-antimatter imbalance. The Big Bang should have created equal amounts of both.
But it didn't. We're here, and the antimatter is gone.
Exactly. Why is the universe made of matter? Studying how neutrinos and antineutrinos oscillate, looking for tiny differences in their behavior, might give us the clue to why matter won out in the end. They might be the reason everything we see exists.
That is an incredible thought. Okay, so to recap this whole deep dive, there are 100 trillion ghost particles streaming through you every single second.
Yeah.
They're so non-interactive they could fly through 1,000,000 kilometers of lead. And yet, we build these massive detectors in the Antarctic ice just to catch 1 in a billion.
Yeah.
All to unlock the secrets of black holes and maybe even the origin of matter itself.
The contrast is just fascinating, isn't it? Something that is so completely all-pervasive, this cosmic rain you can't escape, and yet it's so fundamentally disconnected from the physical world we experience. It really forces you to ask what solid even means.
And that really leaves us with a final provocative thought for you to chew on. If a neutrino can pass through 1,000,000 kilometers of lead, if it can pass straight through the entire solid mass of the Earth without ever slowing down, what does that imply about the actual emptiness of the matter we perceive as being so firm and substantial? Are we and the world around us far more void than we ever imagined?